on this curve, we are required to find the x-intercepts and to show that the tangents to the curve at these x-intercepts are parallel. Now, we know that on the x-intercepts, y is equal to 0. So we plan to use that idea to find the corresponding x-intercepts in this curve. So, like I've just said, at the x-intercepts, we know that y is equals to 0. So that implies that in this case, if y is equals to 0, then we'll have x squared will be equal to 3, which implies that either x is equals to the square root of 3 or x is equals to um, negative square root of 3. So these are basically um, the x-intercepts. Now, the next step is to show that the tangents to the curve at these x-intercepts are parallel, which means that the gradients of that tangent should be equal. Now, to do that, of course, you have to find dy over dx. So let's differentiate this curve term by term. So d over dx of x squared plus d over dx of xy plus d over dx of y squared will be equal to the derivative of 3. Now the derivative of x squared will just be 2x. Here we have to differentiate, we have to use product rule because these are product of two functions. So x multiplied by the derivative of y plus y multiplied by the derivative of x plus here you have to apply chain rule, so 2y dy over dx, and that should be equal to 0. All right, so let's simplify this. So that will be 2x plus x dy over dx plus y plus 2y dy over dx should be equal to 0. Now what we have to do is to move this to the right and factorize. So so that will be x plus 2y dy over dx will be equal to negative y minus 2x if you take this to the right. So which means that dy over dx in this case um, will be equal to negative y minus 2x over x plus 2y. So our plan is to show that at x is equal to square root of 3, this curve will have the same gradient as when x is equal to negative square root of 3. So let's find out. So at x is equal to 3, actually square root of 3, and of course y is equals to 0, um, and y is equal to 0, dy over dx will be equal to negative, of course that will just be 0, so 0 minus 2 root 3 over, so that will be root 3 plus 0, so root 3 plus 0, so this will be equal to negative 2, and at x is equals to negative root 3 and y is equals to 0, then dy over dx will be equal to again that will be 0 minus 2 multiplied by negative root 3 over negative root 3 plus 0. and this will be equal to negative 2 again. So obviously from here we can see that um, because the gradients of the curve at this point is the same, and this gradient represents the gradients of the tangents, it follows that the tangents are parallel. Yeah, so it follows that the tangents are parallel.